Okay, so I passed back your exit tickets from yesterday prior to class starting today. So that's another good little resource to go ahead and look over material in preparation for tomorrow because we have our quiz. Remember, it's on right triangle trig, basically just SOHCAHTOA, probably finding a couple of inverses. Okay. Hello. Okay. Shell. There you go. Mhm. Okay, so let's see. We talked about the quiz tomorrow, which is probably going to take up, I'm thinking at least the majority of the period, probably a good 20, 25 minutes. I want to give you enough time to work on that. What's happening next Thursday, the 28th? That's the exam, the second exam of the 6 weeks. That will have the same material as the quiz, but it's also going to have the law of sines and the law of cosines. In fact, most of you still have that homework assignment from the law of cosines. I'm going to go ahead, if anybody still needs a copy of that, or if you've misplaced it, I'll go ahead and give that to you today, and because we should be able to finish this up before you leave. I don't see why we shouldn't. We were very, very close yesterday. And then we'll talk about when that's going to be due. And then we're going to go ahead and start two-dimensional and three-dimensional geometry, have a small little unit on it, but that will not be on the test next week. The test next week is basically just going to be our trigonometry. All right, so any questions about what's going to be happening? Okay, well, let's get back to those notes. Let's see here. Actually, I think it was this one for you. Okay, so we've been talking about the law of cosines. We did some problems yesterday. We also looked at another formula. If you have a side angle side situation, the included angle between two sides, you can use the formula 1/2 the product of the two sides times the sine of the angle to find the area. And then we went ahead and started talking about what IB refers to as compass bearing. You may see or hear it in other respects as quadrant bearing and true bearing. What was true bearing? Where did you start rotating and in what direction? Okay, you started at true north and you started rotating clockwise. Okay, so to the right. And then you can go all the way back around to 360, one full revolution. Now, what was the difference between that and compass bearing? Compass bearing, you had to start either one of two places. North or south, there you go. Because they're typically going to be written like this. Now, once you decide if it's north or south, basically the positive or negative y-axis, then you rotate right or left, depending on if it's east or west, however far. So compass bearing is going to be restricted to one quadrant. Basically, you'll be going up to 89 point something degrees, because if it's 90, well, then you're going in an exact direction. You could say due east or due north. Okay, so let's take a look at some examples. Draw a diagram to show the direction, then convert from the compass bearing to a true bearing. All right, so let me get a grid here. You know what, I'm going to do it with this, make it look a lot better. There we go. I'm going to go ahead and set this one up the same way. Okay. So let's see here. I want to go south 70 degrees east. Okay, so Hillary, what quadrant would this put me in? 1, 2, 3, or 4? I'm sorry? The lower right one. Okay, she's absolutely right. What quadrant is that? That's the fourth one, yes. When we count the quadrants, remember we always go counterclockwise. Okay, so 1, 2, 3, 4. So yeah, with being south, I'm going to start here, and because it's east, let me go ahead and just say north, south, east, and west. So I'm going to rotate right, let's say right about here. So this is 70 degrees. Okay, there we go. That's a compass bearing. But now he wanted me to go ahead and convert that same measure to a true bearing. So we always start at true north, and we rotate clockwise here. Well, now the measure in one quadrant, remember that's 90. So this difference here is what? Okay, it is going to end up being 110, yes, because the 90 plus the 20. So I'm going to say 110, and then we put that capital T to indicate that we're talking about true bearing. Okay. So the 110 degrees true bearing is exactly the same as saying south 70 degrees east. They would both stop. We call that a terminal side in trigonometry. They both stop in the exact same position. Hey. Okay, so let's try this one. North 24 degrees west. Okay, Sierra, What quadrant would that put me in? 1, 2, 3, or 4? Okay, being 2, yes. So here's north, south, east, west. Okay, so we choose north because that's the first one, and then we rotate left. So probably something like this. That right there, I'll write that better. Let me do this. So this right here would be 24 degrees. Okay, so that would be north, 24 degrees west. So I want to rewrite that as a true bearing, so I'm going to start here, rotate all the way around. Okay. So basically what we're talking about, what's 360 minus 24? 336. So as a true bearing, 336 degrees true bearing. There it is, and that's all there is to that. Yes, sir.
So for like the 24 degrees, why didn't we just like, so like if this is like 24, why didn't we also like that 24? Does that kind of make sense?
What do you mean?
So like we could we also like make the other, could we also like invert it kind of, or like,
Show me what you mean.
yeah.
Okay.
So why didn't we draw it like that, making this 24?
Oh, because you're coming off the original direction given.
Okay, so
Like
north.
this, yes, this one right here. So you'd have to come off of north. So once you're looking at this, you always rotate off of north or you rotate off of south. Now, it can change the way you're talking about if it's worded in a particular way. Like there was a problem I was looking at in pre-calculus the other day, and it said the measurement was, what was it? It was 30 degrees north of west. So in that case, because of the way it was said, because it said north of west, then that would be 30 degrees. Okay. Yes. So it's all in the way it's stated. But if it's given to you in this form, you always rotate off the positive or the negative y-axis first. All right, good, good, good. So how are we doing on directions? Yes, ma'am, Evelyn. Oh, yeah, you can actually rotate in the opposite direction. And it's not that we have a negative measure. That just tells you the direction that you're going to go. Like typically, how many of you have really done a whole lot in trigonometry? Kind of, sort of. I mean, with the unit circle, okay. With the unit circle, we always start to rotate counterclockwise, and we begin from what we call standard position. Standard position is the positive x-axis. So a normal measure, like say I wanted to show 50 degrees, well, from here I would rotate counterclockwise. This would be 50 degrees. But if an angle is negative, we're not saying that it's a negative measure. The negative simply tells me the direction that I would rotate. If you wrote negative 24, if you were trying to write it as a true bearing, yes. Okay. But typically, even though they would be considered what's called coterminal, you would probably still just rotate all the way around. So instead of saying the negative 24, you would go ahead and go all the way and say the 336. But I mean, with what we know, it would still be congruent. Okay. Good, good, good. Questions? Mm-hmm. So we're heading in the right direction? Okay. All right, well, let's see. Next problem. We've only got 2, and then we are done. So it says an airplane flies 200 kilometers on a course of 137 degrees true bearing. How far east of its starting point is it? Okay, so let me go ahead. I'm going to do this down here where I just have a little more room. And I can actually use this for both of my problems here. Okay. So it says it's going to fly on a course 137 degrees true bearing. So what quadrant would that put it in? Okay, it would be in 4, yeah, because the measure of a straight line, a straight angle, is 180 degrees. So 137 is definitely going to be between 90 and 180. So we're probably, I don't know, looking at something like this. Yeah, so this right here is going to be 137 degrees. All right. Now, we know that the plane is flying 200 kilometers. Okay. So that's going to be my distance here, 200 kilometers. So it says, how far east of its starting point is it? Well, let's say that the plane actually hits 200 kilometers right here, where I made that little mark. Let's go ahead and connect it straight back up to the x-axis because we're simply wanting to know, well, how far east of its original position is it? Well, by doing that, what did I give myself? Yeah, what type of triangle though? A right triangle. There we go. I gave myself a right triangle. And all we're trying to do is find this distance here from the starting point to there. Okay, well, is there anything I know about the diagram that can help me out? Okay, Hillary, what do you think? Okay, so 137 minus 90. So what would this little angle be right here?
47.
That would be 47. Okay, so this would be 47 degrees right here. So the whole measure is 137, but just that little one there is 47 degrees. And do we actually have enough information here to find what we need?
Yeah, see, now you can just do the trig.
Now you can just do, yeah, right triangle trig. So let's say this is x because it's the horizontal. Let's see, from the one angle's perspective that I have, 200 would definitely be the hypotenuse, but what would x be?
Um,
X would be the adjacent. So what trig function? Eli says cosine. So I'd go ahead and say cosine of 47 degrees is going to equal the adjacent x over the hypotenuse 200. There we go. And then how would I solve this for x? There you go. Multiply through by 200. So 200, 200. Those are going to cancel. And let's see how far east of its starting point it was. Let me get it out of here. So 200. Okay, cosine, what was it, 47? Okay. All right. So about 136.4 kilometers east of where it started. So 136.4 kilometers. Okay. Any questions? Anybody having a hard time? Okay. Nobody's experiencing any turbulence because it was a plane run. I was just winging it when I said it. You know, we only have a couple months left. You're going to miss it when it's gone. I'm telling you. All right. I know what some people are saying. Well, we won't know until it's gone. So, okay. All right. Well, let's do number 9, our last one. At noon, a ship leaves port and travels at 8 kilometers per hour along a straight course in the direction of north 25 degrees east. At 2 p.m., a second ship leaves the same port and travels 9 kilometers per hour in the direction of south 45 degrees east. The radio communication between the two ships has a range of 75 kilometers. Will the two ships be able to communicate by radio at 6 p.m.? All right, so let's go ahead and do this. We'll work the problem together, but try to draw the diagram. Draw the picture of what's happening. Okay. So let me give you a couple of minutes here. And if you feel confident enough with your diagram and you know exactly what to do, by all means, go ahead and solve the problem. Okay, that's 2 minutes. You may not be done. That's okay. All right, so let me go ahead and see if I can catch up to you folks. So this first ship leaves at noon, and it goes in the direction north 25 degrees east. So what quadrant would that be? Quadrant 1, okay. So we're going to travel northeast. So let's say maybe, okay, right here. Let's say this is 25 degrees. Okay, then we got a second ship that leaves at 2 p.m., 9 kilometers per hour, south 45 degrees east. So that would put me in what quadrant? Okay, 4. So again, we start on the southern, okay, the negative y-axis, rotate left because it's east. Okay, okay. Wait. Yeah, right side. What am I talking about? Okay, south 45 degrees east. So let's say like this right here. Okay, so this would be 45 degrees. And now we're talking about these ships, the distance between them. Will they be able to communicate with each other? So here's the thing. What would the length of this one side in the first quadrant be? There you go. Is everybody okay with where we're getting the 48? Because remember, distance is equal to what? Speed times time. Okay. So the first ship, the distance it's traveled is going to be, it was, what was it? Okay, 8 kilometers per hour. Okay. 8 kilometers per hour times 6 hours. Yeah, because it left at noon, and we want to know at 6 p.m. can they communicate with each other. Okay, and of course the hours are going to cancel, so there's 48 kilometers. Okay, so this is 48 km. And then you can do the same thing for the other one. 2 p.m., so it's only had 4 hours, so what should that one be? 36. Okay. Okay. Is everybody okay with that? Okay. Well, what do I do from here?
Just solve for the distance.
Solve for the distance. So from here to here, the position of the ship, so let's say that's x. But how can I do that? Well, no, because it's not a right triangle. See, this one right here is at 45, so I know that this one would be 45, but is this one right here 45 as well? No. In fact, what would that one be? It's 65. So this is 65 degrees, so that means that this angle here is what? Oh, it's not acute. I mean, it looks pretty good, but it's not acute. So, I thought that was funny. Okay, 110 degrees. You weren't here yesterday. I did a really good joke about drinking and deriving. So. Yeah. Okay. Is everybody okay with the fact that that's 110? See, now we have enough information to go ahead and find x, but is it law of sines or law of cosines? Law of cosines. Okay. Because we have a side angle side situation, right? Can anybody tell me what the equation would be? How would I start it? Okay, so x squared. 48 squared plus what? 36 squared. Minus 2 times 48 times 36 times the cosine of 110 degrees. Okay. And then, of course, to get the distance, I would only need to take the square root here. All right, so I'm going to type this in using the keyboard and mouse. That'll just go a lot faster. So let's see here. Square root 48 squared plus 36 squared minus 2 times 48 times 36 times the cosine of, it was 110, right? Okay. So when I push enter, I'm getting 69 point, let's say 2 kilometers. 69.2 kilometers. Now, the original question, this is really just yes or no. They can only communicate if the distance between them is 75 kilometers or less. Will the two ships be able to communicate by 6 p.m.? Yes. Yes. questions. Did anybody actually not only get the diagram but continue into the final answer?
So I
Tried.
but what I did is I didn't count I didn't do the line you labeled X. I just thought I should just do the vertical distance on those, like as if I was measuring the distance of the axis.
So like you just connected them maybe perpendicular to the axis
Yeah.
and said that was 36 and that was 48?
Um. Yes.
Did that work?
Well, was it the same value because it's shorter? Because it's vertical distance instead of like that.
Well, I mean, yeah, visually, but if you're still using the same information.
So the way I used right triangle trick, I didn't
Yeah.
use log cosines because what I did is I used like.
And you know what? Come to think of it, it might not work because
Just the way I
of the
worked
right triangle. Okay.
where the distance was much bigger.
I am kind of curious how far off were you?
I think my answer is like it just happened to work out. Oh, I got 68.9.
68.9?
Yeah, so it's like.
So that's really close.
Yeah, so it's like it's not the right answer because I did it wrong.
Mm.
It's close enough to the right answer to where I guess if I did that on.
Yeah, but I mean, compared to the two, 68.9, 69.2, for me, that would be acceptable. Again, when it comes to the paper exams, yeah.
They're simply asking yes or no.
I would be really surprised if a grader did not accept that. Because, I mean, on the test, they'll carry an error forward and you'll still get points for that. You can still get points for showing work, but writing down the correct formulas, at least demonstrating that you have knowledge of what the problem is talking about. So I don't think that would be a huge problem. Well, now you're saying completely wrong, but you're saying 68.9, right?
I mean, it's not the right answer.
Yeah.
In the sense that the number I got just happened to be close to the right answer, but it's not. But it's like I made a round.
I see what you're saying. I see what you're saying.
I just happened to do the wrong. Like I did the.
I mean, not saying it this way, but you kind of lucked into the answer.
Yeah. I mean.
I don't know. I don't know. That's a good question. I don't know how they would respond to that. I mean, your work would get you to that answer. Your work would have to justify it. So at the very least, you get points for error carried forward.
Even if
I don't
use a lot of cosines, like even if I use.
Well, I mean, the thing about this test is, there's not going to be just one single way to work these problems. So I would think it should be fine. I'd be really surprised if they did take off points for that. But there you go. Okay. All right, questions. All right, well, that is all I have. So let me shut this down because I believe that's it. Right? Then after this, it goes into law of cosines homework.